Hi everyone, today we're going to talk about functions. Now, if you haven't already watched the videos on YouTube for an introduction to functions part 1 and part 2, please stop this video and go watch those two videos. Otherwise, this is going to be kind of confusing. Okay, so to define a function is a relationship in which each input has exactly one associated output. Let's talk about this first example. Tu and Khadija are both first-year college students at Highline. They're wanting to start a snail mail group where everyone in the group sends letters to every other person in the group. At first, the group starts off small, only containing Tu and Khadija, so there's a total of 2 letters sent. Tu sends one to Khadija, and Khadija sends one to Tu. So here's Tu, and Tu sends a letter to Khadija, and vice versa. So the total amount of letters being sent when there are 2 people are 2 letters. Reina decides to join the snail mail group, and now there is a total of 6 letters being sent out. So if I added Reina here, then Reina would send one to Tu, Tu would send one to Reina, Reina would send one to Khadija, Khadija would send one to Reina. So if I counted the arrows, there'd be 1, 2, 3, 4, 5, 6. So that's how we're getting that number there. And we want to complete the table. So if we added an additional person, so let's say Mr. Kwan decides to join this mailing group. So Mr. Kwan would send one to Khadija, Khadija would send one to Mr. Kwan. Let me just fill in the rest of these arrows. Ooh, there are a lot of arrows. All right, let's see if we can count those properly. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12. That doesn't seem to be growing in a linear fashion. Have you noticed that? So let me just point that out. Growing from 2 to 6, that is adding 4. And then going from 6 to 12, that is adding 6. So notice that because that's not the same amount, this is not growing in a linear fashion. Part B asks us, do you see a pattern? Can you come up with a general rule for figuring out the number of letters being sent from any number of people? I'm not going to draw out this scenario for 5 people because it's going to get really messy and there's going to be a lot of arrows bouncing around. But hopefully you can see that each person, let's make a list of 5 people. So here's Mr. Kwan, Reina, Tu, Khadija, and let's say one more person joins on. And let's say that person is Tim. Think about how many letters will Mr. Kwan send out? Well, he's going to send one to everyone that's not him. So he's going to send out 4, and everyone else is going to send out 4 as well, because each person is sending a letter to everyone that is not themselves. And so if I added all of these up together, it's 4 plus 4 plus 4, so that would be 20. Do you see the pattern yet? So the pattern is to figure out how many letters are being sent. So number of letters being sent is equal to the number of people in the group multiplied by the number of people in the group minus 1. So in this example, you can see that here the way that we got this was 4 times 5 equals 20, and 3 times 4 equals 12, and 2 times 3 equals 6, and 1 times 2 equals 2. So that's how we're getting that. And if we want to think about maybe function notation, which we've alluded to in the previous videos, another way we could write this is f of x is equal to x times x minus 1. Now, do we think that this is a function? Remember, a function means that for each input, there is exactly one associated output. So no matter what input you have, which is represented by the number of people in the group, there's only going to be one specific number of letters for however many people are in the group. So we want to say, yes, this represents a function. Okay. Now, a lot of times we represent the function as a graph, and this next thing called the vertical line test gives us the ability to tell if a graph that we're looking at is a function or not. So basically, the vertical line test says that if you're looking at a graph and you can draw any vertical line that will intersect or cross the graph at 2 different points, then it is not a function. Otherwise, the graph does represent a function. So this next example wants us to look at the graphs below and determine whether or not they are a function. If they are a function, then we also want to talk about the domain and range of the function. Again, if you haven't seen those intro videos to functions, that's where we talk about domain and range, so go back and watch those. Now, this first graph is a circle, so the vertical line test says that if I draw any vertical line and that vertical line intersects the graph at more than one place, which it does here, then it is not a function. So this is not a function. So we don't need to talk about domain and range for that one since it's not a function. Let's move on to part B. Notice that if I drew any vertical line, some of these are not straight, but just bear with me. Each of these vertical lines intersects the graph at exactly one place, no matter how I draw the vertical line. So what that tells us is this is a function. And because it's a function, whenever we are dealing with functions, we can talk about the domain and we can talk about the range. Recall from their videos that domain is all the set of input values or the x values. So if this is our y-axis and this is our x-axis, then we want to know all the x values we can plug into our function. Now notice that there are these arrows here which indicate that the graph really continues on forever in both directions. And they're kind of spreading both to the left and to the right, which means that all of these x values are going to be covered somewhere as we continue drawing the graph. And so how we indicate that is by using interval notation, which again we talked about previously. And so because all of the x values are covered, our domain is going to be everything between negative infinity and positive infinity. Now, let's talk about the range, which is not the same as the domain. The range is all of the y values or the output values that we're looking at. Notice that our graph doesn't go anywhere down here. It's only the lowest point is right here at this point, which we call the vertex, and we'll talk about that more later. But basically the lowest point is there, and then all the other points are above that. And so we want to think about all the y values starting here and going up, because those are the only values that are in our range. So looking back at that lowest point, the y value there is -2, And I want to put a bracket instead of parentheses since that point is included in our graph. So it's going to be -2 to infinity, like that. That is our range.